Although central air conditioners differ from model to model, they operate on similar principles. In this video, we will address how central air conditioners work, as well as potential problems you may encounter. Included among the components that make up a central air system is a condensing unit, which is located outside the home. The condensing unit contains the air conditioner condenser coils, the compressor, and the condenser fan motor. The evaporator coils, or cooling coils, are located inside the home and are mounted on top of a furnace or air handler. The furnace or air handler uses a circulation blower fan to draw air through the return vent, blow it past the evaporator coils, and force the air through the home's venting. The room air is then drawn back through the return, and the airflow cycle continues. Once the room air has cooled sufficiently, the wall thermostat signals the circulation blower fan and condensing unit to turn off until the room temperature increases. This process can be broken down into three main factors: temperature control, cooling, and air circulation. The temperature in the home is regulated by the wall thermostat. The thermostat can be powered by the furnace control board or by batteries. The thermostat must be in a central location in the home, positioned at eye level and away from direct sunlight for proper temperature regulation. When the thermostat detects an increase in temperature, it closes the cooling circuit, allowing voltage to travel to the control board. The control board uses a time sequence to send 120 volts of alternating current to the circulation blower fan motor in the furnace and 24 volts to the condensing unit contactor. When the condensing unit contactor is energized, it allows 240 volts to flow through a nearby disconnect box to the compressor and condenser fan motor. The disconnect box, which provides a way to turn off power to the condensing unit outside, includes a cartridge which may contain fuses. If the compressor and condenser fan motor fail to work, the disconnect box fuses can be tested for continuity to determine if a continuous electrical path is present. The compressor acts as a pump, compressing refrigerant in gas form into the condenser coils, where the gas is condensed into a hot liquid. The condenser coils dissipate the heat as the liquid travels through them, and a fan is used to assist the coils in this process. Once the refrigerant has passed through the condenser coils, it travels to the evaporator coils, located on the furnace or air handler. As the refrigerant liquid enters the coils, it expands into a gas, which makes the coils cold. The gas flows through the coils to a suction line attached to the compressor. The compressor converts the gas back into a liquid, and the cooling cycle continues. The humidity in the air condenses on the cold evaporator coils and drips down into a set of collection trays. The trays are attached to either a condensate pump or a floor drain. It's important to keep the condenser clean. If leaves or other debris clog the coils, the heat will not be dissipated properly, and the system will not function efficiently. You can use a garden hose to clean the condenser by spraying the coils from the inside out. The most important factor in efficient operation is airflow. To ensure proper airflow, the air filter should be checked monthly and replaced as needed. There are several types of filters available and range from 1 to 5 inches thick. The filter can be installed into the slot in the return or in an air cleaner. Some homes will have an electronic air filter, which is powered by the furnace or air handler control board when the circulation blower fan turns on. The blower fan motor can run at multiple speeds to improve efficiency. Lower speeds are used when the furnace is heating, and higher speeds are used for air conditioning. If the circulation blower fan becomes noisy during use, the set screw on the blower wheel may have loosened, causing the wheel to wobble on the motor shaft. You can fix this problem by tightening or replacing the screw, or replacing the blower wheel altogether.